Hey there, Math 20-1s. We're going to go over this Chapter 3 assignment practice question sheet that I created for you guys. Now, let me just see if this is the right sheet. Yep, this is the right one. So all these kind of questions you'll see on the exam tomorrow, but it will also include that one kind of question where you have the multiple points. You have to use the system of equations to solve it. So let's quickly go through these here. So let's see. Let me get the right pen I want to use today. So because of the 3 in the front and being positive, the positive part doesn't really matter for the first part, whether it's wide or narrow. But because of the 3 in the front, this is going to be, oh, that's not the right word. This is going to be a narrow graph, right? The larger this value is compared to 1, the more narrow it's going to get. Right? It's going to disappear there. And then the less it is, closer to 0, the more wide it's going to be. So I'm probably going to do both of these at the same time. Like you notice that this one here is -2, but we're going to ignore the negative, and we're just going to deal with the 2 itself. And the 2, because it is bigger than 1, this is a narrow graph. All right? And then we want to determine the vertex for both of these. So the vertex for this one over here, using, let's use this knowledge here, is using that and this number here, the 5 and the -27. Remember that the 5 technically means minus a +5, means the p-value is actually 5, but the q is still -27. Oops, I'm writing myself there. Okay? Then over here, because we don't have any parentheses, technically we can rewrite this as -2 bracket x minus 0 bracket squared plus 50. These essentially are the same thing, but usually when you say +0, we just don't write +0. So this is going to be 0, 50. All right? Let's go over this one over here. Okay, axis of symmetry. Now, as long as you know the x value of the vertex, you know the axis of symmetry. So this one's going to be 5, and this one over here is going to be 0. Direction of opening. Okay, because the 3 is positive, means it's going to be opening upwards. Kind of like a little smile face. It's a positive smile. So this is going to be upwards. All right, and because the 2 is negative, that seems like a bad mood. So you should get a little frowny face. You get a negative there. So it's opening down. Okay. Now, because it's opening up, this bottom point right here, that is a min. All right, it's the lowest the graph goes. So this is the minimum point. This is my min of, and then we just use the y value. I'm talking about the min and max. I'm just talking about the y values here. So this is the min of -27. And over here, because this is the top of the graph, that's the maximum point it's going to be. All right, so that's the highest it's going to go. So this is going to be a max of 50. Right. Now the domain for both these graphs, pretty simple. You guys should just remember that all quadratics are XER. You can see this back in Math 30-1. When you do this, that all polynomials are XER. The range is going to be the one that changes quite a bit. So the range for these, I'm going to move my head out of the way here so I can write the range nicer. So the range for these is going to be different for each one. It's kind of based on this min-max statement up here, the minimum, and it's kind of opening upwards. Because it's opening upwards, if that's going to be the bottom of my graph, it's going to be everything more than that, greater than that point. So this is going to have a greater than or equal to, and then 27. And for completion's sake, we like to put the XER. If you forget that part, I'm not too much of a stickler about that. They will be in Math 30-1 though. Because this is going down, you're going to start at the top and everything lower than that value, less than that value. Starting at the very top up here, kind of working your way down. So everything less than the 50. It's all about the y value of my vertex. Okay. To find these x and y intercepts, to find x and y intercepts of these graphs, you've got to remember what to make 0. So in this equation here, I wonder if I can find this one on a different sheet somewhere, but let's not worry about that. To find the x-intercept, you have to remember to make y is equal to 0. And to find the y-intercept, you make x equal to 0. All right, so this equation, I just have to write this down here, 3 minus 5. Was it minus 27? Yeah, minus 27. Okay. I'm going to write the other equation over here too, so I can do it at the same time. Negative 2x squared plus. Was it plus 50? Yeah, plus 50. Okay, so now I got these equations. So what I'm going to do is I'm going to make, for the x-intercept, I'm going to make y is equal to 0. So I'll write a 0 in the y spot. And then I'm going to have to rearrange these equations. But actually, before I even start, I'm moving my head around here. Before I even start, I'm probably going to 27. I'm going to want to just kind of sketch it out. Determine, are there going to be x-intercepts or not? So I'm going to just put a little sketch right here. My vertex 5, negative 27, so somewhere down in quadrant 4. And it's opening upwards. So it looks like it's going to cross twice. So it looks like I'm looking for 2 answers. And the same thing over here, I probably want to do the same thing. So I'll just do a little sketch here. My vertex for this one is 0 and 50, opening downwards. Yeah, it looks like it's crossing 2 times. So you're going to want to find both those answers. You can look at the second one here. I know that's a symmetrical graph. So my answers are going to be the same number, but opposite sign, like positive 5 versus negative 5. But the other one here, it's kind of moved over a little to the side, so the numbers are not going to be the same, but there's going to definitely be 2 of them. So I'll make it equal to 0. And our first step now is that we're going to take this 27 here. I'm going to add it over to the other side. Kind of move it over to the other side there. So I'm going to get a 27 on this side now. Okay. And then I'm going to take that 3 that's in front of this squared piece. The goal here is to get this squared piece by itself. So I'm going to remove all the other numbers from around it. So I'm going to divide by 3. I'm going to get 9. Then you look at this and say, okay, what 2 numbers can I square and get 9? So then you also think, okay, it's 3 squared. Okay, so 3 squared could be my answer. So what could I put in here for the brackets that would make x minus 5 a 3? Because then when I square it, I'm going to get a 9 out of it. So one way to think about that is maybe to think, okay, I want the x minus 5 to be a 3, because then I could square it and get my 9. Okay, so let's see. 8. So I'd add over this 5 here. And I get 8. And I can just double check that up in this equation. Say 8 minus 5 is 3. 3 squared is 9. Oh, that seems like that should work. Check mark so far. But is there any other number that I can square and get 9? I'm thinking, negative 3. So negative 3, I can also square and get 9. So if I can get the brackets part here to be a negative 3, then that whatever ends up being negative 3, if it's squared, it'd be a positive 9. So it should work out. And I'm going to go test it later on and see if that actually works. So I'm going to add over the 5. Let's just add over the 5 again. So add over that 5. And I'm going to get x equal to 2 this time. Okay, so I put it back in here. So I'm going to put a little 2 in here. So 2 minus 5 is negative 3. Negative 3 squared is 9. So that should work as well. I'm just going to do that, put that as a different color. Now another way to think about it, because this happens all the time, when you take the square root of this side to get rid of the square, that's going to cancel it out. You take the square root of this side as well, just automatically put the plus and minus there. As long as it's not 0 or a negative number, you're going to get 2 answers. If it's 0, then you get 1 answer. If it's negative, you get no answers. And you determine if you get no answers before you even start the question. All right, over here, I'm going to do the same thing. I'm going to put a 0 here. Negative 2x squared plus 50. I'm going to minus over the 50 this time. I'll move my head to the side here. There we go. So I'm going to get negative 50. What is up there? Okay, negative 50 is equal to negative 2x squared. You divide by negative 2 on both of these. So divide by negative 2, divide by negative 2. You get 25. Okay, this one's a little bit easier to see the two answers. What number can I square to get 25? Well, I know I can square 5 and get 25, but I can also square negative 5. But when in doubt, just take the square root. Because it's not 0, I'm just going to put plus and minus on that. And there we go, get your two answers. Yeah. My x-intercept's a little bit easier to do. No rearranging needed. You can just plug it right into your calculator after you do this first step. So y is equal to 3, that's an equal sign, 0 minus 5 squared minus 27. Just blam, plug it into your calculator. See what happens. I'm just going to do that right now. I'm going to pull my calculator up. So I'm going to show the steps, but if you just write this exactly the way it is in your calculator, you get the right answer. So 0 minus 5 is negative 5. Negative 5 squared is 25. Minus 27. So 3 times 25, which is 75. Because remember, we've got to do order of operations here. Minus 27. 48. And that's just enough right there. Like, you put the little int for intercept. It's in the box for y-intercept, so it makes sense what it is. Let's do this other side here. I'm going to put a 0 in the x spot. Okay, now very common mistake here is say 0 squared is 0. So this just ends up being minus 2 or negative 2. But remember, anything times 0 is also 0. So this actually ends up being 2 times 0. Then this ends up being 0 plus 50. Watch out if that was minus 50. If 0 it would end up being negative. So this just ends up being positive 50. And I kind of knew that already. Because if you look back at my vertex, 0, 50. When the x is equal to 0, I got a 50. So, y. Cool. There's the first chart. Okay? If that kind of makes sense, hopefully it's all just a refresher at this point. And then we're going to scroll down to this next one here. Now, this one here, it's like the chart, but you're just filling it based on what you see on the graph. You could see the vertex, so you write the vertex. You could see the x and y intercepts, so you just write them out. Okay? Now, the x and y intercepts are pretty nice because they're points that I can use later on to solve this question if I want to create the equation, which I have to do later on. Well, first of all, let's do the vertex here. So we've got negative 1, 9. Remember, that is also the P and the Q. We're going to use that for later. I'm just going to mention that right now. Axis of symmetry, because I know the vertex is negative 1, 9. My axis is negative 9. My x-intercepts are 2 and negative 4. My y-intercept is 8. If you want to put them as a point, you can. We're going to use it as a point later on. Opening, it's opening downwards, obviously. You can see it. You can actually see it. It's just going down. This is a max point. It's at the top of my graph of 9, so that's at the very top. My domain, always XER. So I'm just going to write that down here. Right? My range, because it's the max, will be the top of the graph and everything less than whatever the top value is. Which is the same as my max statement, essentially. There you go. Okay, now what we want to do is we want to create the equation for this graph. And we know the P and the Q right now, so I can write that down at the bottom here. So my A value, which we don't know, it looks like it's supposed to be negative because it's opening down. But is it negative 1? Is it negative 2? Is it negative something? Negative a half? Who knows? So I'm going to take this and go x minus my p. But my p is a negative, so we got a negative, negative. So this actually turns positive here. So be very careful about that. That one kind of flips its sign. Plus 9. But to find the a, we need another point. And what other point can I use? Well, we've got 3 points. Actually, this graph there's like 6 points I can use on this graph. But there's 3 really good points. The y-intercept and either one of these x-intercepts. Either one of those 3 points is going to give me the same answer. Doesn't matter which one you pick. If you want to verify it, you could do it for all 3 and see if you get the same a value. Just don't use the vertex. The vertex causes problems, so don't do that. All right? So, okay. So let's use 0, 8. Let's use the y-intercept. Yeah. So I'm going to use the y-intercept. I'm going to use the point 0, 8. Right? So if I put a 0 into this graph, I'm going to get an 8 out. So let's do the math here. 0 plus 1 is 1. 1 squared is 1. So this is going to be a plus 9 is equal to 8. Oh, okay. That could just be a 1 here. You can't really tell. It's a 1 right there. Right, because 1 squared is 1. So I'm going to take the 9. I'm going to minus it over to the other side. Get negative 1. Hey, it worked out. So we got a negative. I thought it was going to be negative. 1 is not very exciting, but at least we got the negative. So it's negative 1 bracket x plus 1, because that's my p, plus 9. That's a square there. There you go. You can graph it and just see if it actually matches, but I won't do that. I won't do that. This filter has a lot of lag to it. I wonder if I can find a filter that doesn't have so much lag. What are my favorites? This better? Yeah. Yeah, this is better. It doesn't have so much lag to it. Okay. Oh yeah, I can do that. Oh, I don't want to do that. So the same idea for this one. We're trying to determine the equation of this graph. It's given us a few points here. It gives us the vertex, which is kind of nice. As long as I know the vertex, this little crossing's in the way. If I know the vertex, I'm just going to write that here, is 5, 0, then I know the p and the q. So far I can start off my equation by doing this. X minus 5, because remember you have to flip that p1 around, plus 0. If you want to put the plus 0, you can. You don't necessarily have to write that. But now I've got to find out the a. It looks like it's supposed to be negative. Negative 1, negative 2, negative a half, negative something. I don't know yet. So I'm going to take this point. I'm going to take either one of these points. Doesn't matter. I'm going to take the 6 for reasons. But that point is 6, negative 2. Okay, so I'm going to use the point 6, negative 2. 6, negative 2. So if I put in a 6 into this equation, I need to get a negative 2 out. I'm just going to ignore the 0. So I'm going to do a little bit of math here. 1 minus 5, mental math, sorry. 1 minus 5 is 1. 1 squared is 1. So this is going to be 1. A is equal to 2. Negative 2, sorry. So A is equal to negative 2. Negative, but now it's 2. So my equation is going to be negative 2 bracket x minus 5 squared. Oh, I should be putting boxes around my answers. I'm trying to find them. Let's go back up here. Make it a little bit clearer where my eye should be directed. Like, oh, these ones are okay. I'll leave this alone. Same idea. Question 4. Actually, I should change this to be one of those system of equation ones, but whatever. We got the p and the q. We got a point here, so we can find out what the a is by using that other point. Plus 0. Plus 0. So I'm going to put a 1 in. I need to get a 3 out. So I'll put a 1 in the x spot, and I got to get a 3 out. So you got to watch out for that 2. It becomes a negative 2 down here. Otherwise, you're going to get a third rather than 3, like the answer is right here. 1 minus 2 is negative 1. Negative 1 squared is 1a. So a is 3. So my equation is going to be 3 bracket x minus 2 squared. That's it. You don't have to put the plus 0 if you don't want to. If you do, I don't care. Mathematically, it's still right. What kind of Vikings wear glasses? I don't know. Cool. Okay. The next question's here. So it says here, complete the square and identify the vertex. So if I look at this, I don't know where the vertex is. I kind of know that I know it's opening upwards. I know the y-intercept is 13, but I don't know anything else about this graph. All right. Now, I don't know where it crosses the x-axis. I don't know where's the vertex. The key one is where's the vertex. So I have to change this form to vertex form. So this is that 3-step process. Technically, you can get away with 2 steps. All right? 1, 2. But then you could put another step here. This question. Okay. So you could skip this second last step most of the time. And I'll show you how you can do that. Well, I'll write it in after the fact, but I'll show you that in reality, this second line and this last line are the most important. So you look at the front, you notice there's a 1. Okay, so I'll factor the 1 out. I know it doesn't do too much, but I'm going to emphasize that I want to factor out whatever's in front of the equation. So in this case, I'll just factor a 1 out. So that 1 is going to be the A value of my A, P, and Q vertex form down here. I'm just trying to find out what the P value is and what the Q value is. So from here, I can go straight down to the bottom and say, oh, to make sure I get -6 here, I have to put a -3 here. I take this number and divide it by 2. And then if I were to multiply this out, do the whole distributive property, all the little rainbow and the foil and stuff, I'm going to get a -3 times a -3 eventually. So I'm going to get a 9. I'm going to put a 9 here. But remember this line here, these 2 lines right now are the same, the top 2 lines. Like this line and this line, they're both the same. So I can't really change this line. So when I multiply this out and I get a 9, I got to minus that 9 at the same time. So you kind of square to get to there. So you square the -3, you get +9. Now the -9, it's always the negative one. The -9 has to come out of the brackets. Just one of the steps we do. You got to pop it out of the brackets. So take the 1, times it by -9, and I get -9. So a -9 pops out. So -9 plus 13, and you get a 4. So now that 4 is down here. So you can see I skipped this middle step. If you were to put the middle step in there, this is what it would look like. Bracket x squared minus 6x plus 9, bracket. That's me multiplying out that bracket on the bottom here. The 9 pops out, you get -9 here, plus 13 here. And then they combine together to get that 4. Okay? But you can see you can just kind of skip that step if you need to, or if you want to. You don't need to. Okay. So we do the same thing on this one. We can do 2 steps here. You can do all 3 steps if you want to. You're going to factor the 3 out. So I'm going to divide everything by, except for the 13, but I'm going to divide the other 2 things by 3. And get 4x here. Leave myself some space here, plus 13. At the bottom, I'm going to have a 3. That's my A value, so that's good. Minus a P value, bracket squared, plus a Q value. I'm trying to fill in the P and the Q here. So take the 4, divide it by 2. I take that 2, and I square it. So -2 times -2 is +4. But then I had to minus that 4 because I'm not allowed to really change the line. I can make it look different. Then I take that 4, the -4, and I have to pop it out of the brackets. So 3 times -4 is -12. -12 plus 13 is 1. And there you go. Oh yeah, down below we have to answer the vertex thing. So we could do the vertex at this point too. You can say vertex is equal to 2, 1. And the one over here, the vertex is 3, 4. That's what this down here is trying to say. Okay, but I'll give you so much space to do 3 lines of work, it doesn't really make any sense. Okay, if you want to put that middle line in there, you can, but this right here is enough. Right? The middle line would look like this if we did it. Oh, squared 4x plus 4 bracket. This would be negative 12 plus 13. There you go. Cool. Let's go down. Let's try another one. Oop. That's the last one. Yeah, that's the last one here. So I'm going to factor out that negative 3. So I'm dividing everything by a negative number this time. So when I divide by a negative, it's going to turn into a positive, right? So negative 3 divided by negative 3 is just x squared. Negative 6 divided by negative 3 is positive 2x. So that's going to flip its sign there. Yep, looking good. So this a value is negative 3. I just have to figure out what is my p value going to be and what's my q value going to be so I can find my vertex. So I take the 2 that's left behind after I divide it by 3, divide by 2. Make sure you keep the sign. This one's positive 2. Oh, sorry. This is positive 1 now. It's positive 2 divided by 2. But like this one here was like negative 6 divided by 2, so you got a negative 3. It's important you have to keep that sign. You square the 1, and then you minus the 1. And then you pop the negative 1 out. So negative 3 times negative 1 is positive 3. 3 plus 3 is 6. Okay, and then down here, we're going to just write our vertex, negative 1, 6. Done! Okay. How was that? That was, well, just a half hour. Didn't take very long to do. I'll see you all tomorrow. Good luck. Yay!